30 is testing you on the IVT. The intermediate value theorem is pretty simple. You have two requirements. One is prove continuity. If you don't prove or show that the function is continuous, then you have to prove, or else you can't use the IVT. Even though the IVT may hold true in some cases, unless you prove continuity, it is not necessarily true. Second is what the IVT states is essentially pretty basic. It's that if you have a graph and you have a boundary point and you have boundaries, you also have y values, you have to hit every y value between those. So what that means is, let's say x equals 0 and this is x equals 3. It's saying that if this value is, let's say, y equals 3, and this value is y equals -1, no matter if the function is continuous, no matter what, you have to hit every value between -1 and 3. For example, sometime you will have to get to y equals 0, whether it be here and your function looks like this, or it be here and your function looks like this. Because it's continuous, you have to hit every single point. So that's pretty intuitive. It's not very hard. So when we go to number 30, it asks you to find the root of the equation. So what the root of an equation means is when the x intersects the y-axis. So for example, if it goes like this is your root. That is the equivalent of saying f of x equals 0, which is the equivalent of saying y equals 0. So essentially it's saying prove that y hits 0. So, sorry, this is the 30a is saying 2x cubed minus x squared equals minus 2x squared minus 2. So first of all, your step is to add everything onto the left side, or move everything to the left side. So you're left with 2x cubed minus x squared plus 2x squared plus 2 equals 0, which simplifies to 2x cubed plus x squared plus 2 equals 0. Then you find the y values of when x are these values. So what that means is you just plug in x. You plug in -2 for x. So when you do that, you're left with -16 plus 4 plus 2 equals -10. And so this is when you evaluate it at x equals -2. When you evaluate this function at x equals -1, you are left with -2 plus 1 plus 2, which equals 1. So what this is saying is that you have some graph at x equals -2, which is this point here, your function has a value of -10. So again, at the point x equals -2, your function has a value of -10. So let's say this is -10. And at the value of 1, your function has a -1, your function has a value of 1. So it's positive. So let's say this is your line, x equals -1, this is 1, and we go there. So then we need to also prove continuity. This is a polynomial. This function right here is a polynomial composed of other continuous functions. So that means it is in itself continuous. So first of all, because it's a continuous function, we've fulfilled the first requirement. It is continuous. Second of all, we've proven that on the boundary, 1 is less than 0 and 1 is greater than 0. So that means during some point along between -2 and -1, this function has to hit 0. Because it hits 0, that means we have found a root. So all you need to do when finding a root is show that the boundaries have opposite signs, or one is positive, one is negative, or one is negative and one is positive. Because if it switches from positive to negative or vice versa, that means it crosses the y equals 0 axis. If it crosses the axis, that means there is a root. So for example, it might not necessarily be here, but it could be like this, or it could be this, or it could be like this. As long as it is -10 here and 1 here, it has to have a root between those two values. So for the next one, it is just as simple. We just go into number b. We say x, -x squared minus x equals 0. Then we plug, so first of all, our question is this continuous? And the answer is yes, it's continuous. Because e to the negative x squared is continuous, minus x is continuous, therefore they are both continuous during the interval 0 and 1. So now we plug in 0 and we see that it's e to the 0 minus 0, which equals 0. This just leads to anything to the 0 power, remember, is just equal to 1. So you're just left with 1. So at 0, the y value is equal to 1. So we can just box that, remember it for later. We can do the same thing with 1. We plug in 1, so we're left with e to the negative 1 minus 1 equals 0. We know that e to the negative 1 is same as 1 over e minus 1 equals 0. So I don't know if you guys are allowed a calculator on the test. However, oh, sorry, here's my work from down here. But even if you're not allowed to calculate on the test, we can determine that this value is negative because we know that e is about 2.5. So it's saying 1 divided by 2.5, which is like 0.3 or something, 0.6, minus 1 is negative. So we can just tell that this is some fraction that's smaller than 1, minus 1. So overall, this is going to be some negative value. Negative. So then we can just write at 1 equals negative. So first of all, we've proven so you just need to write on your test, e to the negative x squared minus x is continuous, and then that pretty much proves this first step. Then the second part is you just need to prove the boundaries. So we've proven that at x equals 0, your y value is 1. Then you've proven at 1, your y value is something negative. It doesn't matter. Even if it's negative 0.1, it's still fine. So we're saying this is x equals 1. So at 1, which is the boundary mark, your y value is negative. And so that just means you've proven that there is a root, because no matter what, it has to change from positive to negative, which means that it has to cross the 0 line, whether it be like this, this, or this. And we also know that the root is, again, we have to remember that the root just means when the function crosses the the x-axis. Shit, this is x. Oh, this is y. Or when y equals 0. So when so if we prove that it crosses this line right here where y is 0, or aka the x-axis, or when f of x is 0, then we've proven that there's a root. So you're just gonna write that out. Just say, because one side is positive, one side is negative, therefore there is a root in this boundary. So you just, and notation wise, I just write the 3 dots, which means therefore, just say, since at x equals 0, the function is positive, and at x and y and at y equals and at x equals 1, the function is negative, there is necessarily, I don't know how to spell that word, but there is necessarily a root